What if we could ride explosions to the stars? It sounds like science fiction or a line from a dystopian novel. But nuclear pulse propulsion is a real concept. A concept so audacious, so dangerous, that it borders on madness. And yet, it might be one of the few ways to move massive payloads across the interstellar void. The idea is simple in theory, but staggering in execution. Detonate a series of nuclear bombs behind a spacecraft, and ride the shockwaves like a surfer rides the ocean. Each explosion propels the ship forward, boom by boom by boom, accelerating it to a fraction of the speed of light. This method is known as Project Orion, originally proposed in the late 1950s. Back then, visionaries believed that a spaceship the size of a skyscraper could be launched from Earth using thousands of small nuclear detonations. The advantages? Massive thrust, high efficiency, and the ability to carry heavy crews and cargo. But here's the catch. It's incredibly dangerous. For starters, the pusher plate, the giant shield that absorbs the blast, must endure hundreds or thousands of nuclear explosions without melting, cracking, or being vaporized. That's no ordinary engineering problem. It's a test of material science on a scale we've never faced. Then there's the shock absorption system. Each detonation generates an enormous jolt. Without dampening, those forces would crush the crew. The ship must absorb the energy of nuclear bombs while keeping the passengers inside feeling like they're on a gentle cruise. And what about the nuclear devices themselves? Each one must be deployed and detonated with absolute precision, timed to milliseconds, positioned at exact distances. One misfire, one mistimed blast, and the entire mission could end in catastrophe. Then we have radiation, the invisible killer. The repeated nuclear detonations would unleash gamma rays, neutrons, and electromagnetic pulses. Without massive radiation shielding, both the crew and the ship's systems would be slowly cooked. The spacecraft itself would become increasingly radioactive over time, posing long-term risks to both passengers and electronics. In essence, the crew would be riding inside a mobile nuclear reactor, one that periodically explodes behind them. And let's not forget Earth. Launching a nuclear pulse ship from our planet would blanket the surface with fallout, atmospheric contamination, political backlash, global panic. All would be guaranteed. For this reason, most modern proposals imagine launching the ship from space, far from Earth's biosphere and public scrutiny. But even in space, the risks don't vanish. Neutron radiation could still affect nearby satellites. The ship's radioactivity would persist. Debris from detonations could scatter unpredictable trajectories. And there's always the question of what happens if something goes wrong with an armed nuclear spacecraft hurtling through the void. Still, the potential payoff is enormous. No other propulsion system known today can accelerate a heavy spacecraft, complete with crew, habitats, equipment, and shielding, to significant fractions of light speed. Nuclear pulse propulsion might be the only known technology that can move something big, really big, across interstellar distances in a human lifetime. That's why the idea refuses to die. Some newer concepts, like miniaturized nuclear pulse drives, envision smaller, more controlled versions of the Orion plan. Others imagine fusion bombs instead of fission devices to reduce radioactive waste and increase efficiency. Even more speculative are antimatter-catalyzed fusion drives, where small amounts of antimatter trigger fusion reactions with far less fallout. Still, all of these face immense technical and political hurdles. Would the world ever agree to build and launch such a spacecraft? Could we trust it not to fail? And are we willing to accept the risks for the sake of reaching the stars? These are not easy questions, but here's the deeper truth. If humanity wants to leave the cradle of Earth and journey far into the galaxy, we may need to embrace uncomfortable technologies, Sometimes the path forward is not safe, but it is necessary. At Infinity Beyond, we believe that exploring space means confronting our fears and asking, what price are we willing to pay for the stars?